today what we're going to look at are the reactions. We're going to start with hydrolysis, so this first piece is going to be just about hydrolysis. We'll also look at the reaction with ammonia, because it's a special one that we'd like you to look at, and we're going to look at making polyesters. So those are the three key reactions you need to understand. First of all though, we need to know what this word actually means, hydrolysis. So what does hydro normally suggest? Water. Good. Now, for the biologists out there, what does lysis mean? So a cell can be lysed. Breaking. Good. So this means that we're using water to break an ester apart. So as we can see, these were actually our products from yesterday. So it's an equilibrium. So we can finish this off. By using the water to break it in the middle of the ester bond. Now it doesn't matter this year for you to understand the mechanics of it, so which way the oxygen goes, so it doesn't really matter. All we know is it's got to be broken in this area here by water. Here I'd like you to think of water as HOH. So think of it as HOH, makes this a little bit easier to understand. So the H is going to go on here, and the OH is going to go in here, effectively. So we end up with these two start things that we could have made that ester from. So we've got methyl ethanoate turning into methanol and ethanoic acid. It is an equilibrium, so these two will react and go back to being those two again until you get it at the dynamic equilibrium position. If you use acid, the same thing happens, because remember an acid is usually an aqueous solution, so it's got the water in there as well. So you get the same thing. But what's different is if we do it with a base. Because if you ever look at the products here, what's the acidity of an alcohol? Neutral, yeah, so no acidity. But what about the pH of the other product? It's a weak acid. Now if you had alkaline or basic conditions, that won't stay like that. What will it turn into? Good. In this case, ethanoate, it'll turn into the conjugate base. That's exactly what's going to happen. So that's what we're going to show you in this one down here. It still makes methanol. But in this case, it makes the ethanoate ion. What's the other difference that you can see between these two reactions? And it's subtle.
One's an equilibrium and one's not.
Good. One's an equilibrium, whereas one is actually a reaction. So if I was to have something that was made of polyester, for example a shirt, and I spill something that's a strong base, like let's say oven cleaner on it, then that shirt is going to fall apart. But it doesn't fall apart if it's just got water on it. The polymers are more resistant to hydrolysis unless it's an acid or a base. Okay? So that's your first type of reaction. An example of how it's used is to make soap. Soap is made by getting fats or oils, reacting them with a strong base, and then you go on to add the perfumes and so on, and neutralise it and add the perfumes, etc. to make it smell nice. That's how you make soap. In biology, we get these really big molecules called fats or oils. They're non-polar esters. They've got 3 ester groups in them, and they're called triglycerides. You do need to know that word, triglyceride. So the sciencey word for fats and oils, triglyceride. If I react them with sodium hydroxide, which is an experiment you may have done in junior science, then that breaks all 3 of these ester bonds. And what it will do is create, first of all, a very special alcohol. So I'll draw that one. And its proper name is 1,2,3-propan-triol. Yeah, you need to be able to do that one. So I'll write that up. but you also need to know its common name because it's such a useful chemical. Does anyone know what the common name of this is? Glycerol, well done. Glycerol is commonly used as a lubricant. Okay, it's quite an oily type of alcohol, so it's commonly used as a lubricant. It's also a precursor for making nitroglycerin, which is an explosive. So it's got some varied uses. Okay, but the main one that I'd say if I was asked in an exam is that it's used as a lubricant. Okay, so you need to know both of those names. The other thing it makes is 3 lots of, in this case, now I'm going to leave what's connected to that carbon, just to check if we can link it to this other stuff. You're reacting with a base, so what is it going to have bound here?
O negative.
O negative, good. What's going to happen to those sodium ions that are left over? They'll be attracted to it. This is your soap. Okay, and its proper name would be sodium stearate because an 18 carbon carboxylic acid is called stearic acid. So this is called sodium stearate. Or its common name would be soap. Alright, and it's one example. Of course, from different fats you'll make different soaps with different properties. Alright, so that's our first type of reaction, hydrolysis, and a common use, making soap. It also explains why a lot of polyesters need to be cleaned pretty quickly if you get an acid or a base on them. And a lot of the shirts that you guys are wearing have got polyester in them, so if you get acids or bases on them, they need to be cleaned that day. Otherwise the hydrolysis of the ester starts and it's damaged forever. Okay. Any questions about that? We'll stop the video.